Imagine that everything you see around you, people, planets, stars, and even this screen, is just the tiniest tip of an incredibly massive cosmic iceberg. Today, you are going to discover the best-kept secret of the cosmos. Why scientists believe we can only see 5% of everything that exists. And more importantly, you will understand exactly what the remaining 95% is made of, an invisible realm we call dark matter. For centuries, we believed the universe was composed of everything our eyes could see and our telescopes could detect. But in recent decades, a series of perplexing observations began to shatter that paradigm. Galaxies were spinning too fast. Their internal gravity was so strong that, according to all our calculations, they should have torn themselves apart eons ago. Something was holding them together, something that emitted or reflected no light, something invisible. This something is what we call dark matter, and it is the first of the three phantom components that dominate our universe. To understand it, think of a galaxy as a gigantic cosmic pinwheel. The stars on its outer edges move at incredible speeds. According to the laws of gravity, at that speed, these stars should be flung out into intergalactic space. But they aren't. It's as if an invisible force, a skeleton or a cosmic scaffold, was holding them in from the inside. That scaffold is dark matter. It is a substance that does not interact with light, making it completely transparent, but it exerts a powerful gravitational force, shaping the very structure of the cosmos. But the story doesn't end there. Dark matter doesn't just affect individual galaxies. It weaves an invisible cosmic web that spans the entire universe. Astronomers can map this ghostly network by observing how the light from distant galaxies is distorted as it passes through these invisible clusters of dark matter, a phenomenon called gravitational lensing. It's like looking through a warped pane of glass and deducing the shape of the glass itself by how it distorts what's behind it. This cosmic web of dark matter acts as the scaffolding upon which galaxies are built, attracting ordinary matter through gravity to form the stars and planets we can see. Now, let's prepare our minds for the second component, even stranger and more elusive. In the late 1990s, two independent teams of astronomers made a discovery so profound it earned them the Nobel Prize. By studying specific stellar explosions called supernova in distant galaxies, they not only confirmed the universe was expanding, but made the most perplexing find. This expansion is accelerating. It's as if, after throwing the ball into the air, it not only didn't come down, but shot skyward faster and faster. Something is pushing the fabric of space-time, separating galaxies from each other at an ever-increasing rate. We call this mysterious repulsive force dark energy. Dark energy is the dominant force in the universe, constituting approximately 68% of all the energy in the cosmos. It is an inherent property of empty space itself, a kind of anti-gravity that works against the gravitational force pulling matter together. It is responsible for the ultimate fate of the cosmos, driving an expansion that, according to our models, could be eternal, eventually leading to a cold, dark, and empty universe where galaxies are so far apart their light could never reach us. And now we arrive at the place we occupy and everything we know in this cosmic scheme. It is the third and most humble component, ordinary or baryonic matter. This is the 5%. You are that. I am that. All the planets, all the stars, all the galaxies we can observe, all the elements on the periodic table, from the hydrogen in water to the carbon in our bodies, are just this tiny 5%. It is the part of the universe that interacts with light through the electromagnetic force, that forms atoms, that creates complex molecules, and that, in a tiny corner of an average galaxy, allowed life to emerge and question the rest of the invisible universe. But how did we reach this astonishing conclusion? The answer lies in a combination of meticulous observations. The cosmic microwave background, the remnant glow of the Big Bang, is like a baby picture of the universe. By analyzing its tiny temperature fluctuations, cosmologists can calculate the total density of the universe and the proportion of its different components. These measurements, combined with observations of the accelerated expansion and the rotation of galaxies, converge on the same startling conclusion. Our universe is 95% composed of ingredients we don't fully understand. The mystery is profound. What exactly is dark matter? Physicists propose candidates like WIMPs, weakly interacting massive particles, or axions, theoretical particles that do not interact with light. Meanwhile, dark energy could be Einstein's cosmological constant, a vacuum energy. Or it could indicate that our understanding of gravity, as described by general relativity, is incomplete on cosmic scales. So the next time you look at the night sky, remember, the twinkling stars are just the gold dust floating on the surface of a profoundly dark ocean. An ocean made of dark matter, whose skeleton holds galaxies together, and of dark energy, whose invisible force is driving the destiny of everything that exists. We live in a universe of which we only know 5%, and the remaining 95% remains the greatest mystery in science. If the idea that we are immersed in a vast invisible universe that dictates our cosmic destiny has blown your mind, share this video with someone else who loves these mysteries. Leave us a comment telling us what you find most mind-blowing, the dark matter that holds everything together, or the dark energy that is tearing everything apart. Subscribe so that together we can continue exploring the greatest enigmas of the cosmos.